Catus Maximus here. Picked up one of these Dremel Multi-Maxes actually at a local habitat. These, as far as the history of these oscillating tools, and that's what this is just simply a tool that just has a mechanism in here that makes the blade shake back and forth really quickly, as much as 20,000 times a second, but over a short distance, and just kind of slowly erodes and saws. These originally came from the medical industry as bone saws, like in the 70s or 80s, and then a German company called Fine was the first to come out with essentially a consumer-based power tool. And I believe those Fines also use what is this originally this style. And there's been an issue with these various tools with different manufacturers using proprietary mounting systems until a universal system came out that really looks like this type of blade tang to really overcome the issues. Dremel, I believe, was the second company to come out with one of these tools, much cheaper than the Fine, and to kind of popularize them in the United States. Dremel was guilty of coming up with their own mounting system. It looks similar to what is known as the Bosch OIS system, which is what most manufacturers signed up for. It's similar to this ring pin system, except for, if we say look at the spacing on the holes on this, we can see that the Dremels is a smaller diameter. And that was really the big issue with these Dremels, was the fact that they tried coming out with their own proprietary standard, which simply did not fit any of the other standards. It's one of the worst things. That's the first reason I generally not recommend the Dremel, although it is cheap. There's some goods and bads about it. That's one of the real bads, is the proprietary mounting system, and the fact it's not really a contractor grade tool. That'd be the other thing I'd mention. Even though I don't mind this case, it seems to hold the accessories and stuff reasonably well. Allen wrench for the center bolt, so it's easy to replace if you lose it, but you have to have this Allen wrench that's attached to the cord to attach and remove it. The problem I've had with these tools, and I've had a variety of DeWalt's, I've not owned all brands, I've owned Milwaukee's or even an actual original Fine version. Many of them don't have as heavy a duty mechanism up here as they need to. They start to develop play, and with a tool like this where the blade only moves back just a tiny amount, let's get this down to the lowest speed. Got this plugged in. I don't even know if you'll be able to really see it move. There you go. That's all that moves. So lesser mechanisms, I've had Bosch's, particularly the early Bosch's, were terrible. They had plastic parts that would just flatten and wear out super fast, and it would get to a point to where it was running, and you could grab the blade, and it would actually stop moving. And obviously, you're not going to be cutting when that happens. And so that was actually some frustration I found with a variety of these things, until I ran into the Makita TM3010C. This is the one I would recommend if anybody wants a good oscillating tool. That's really the bottom line. Is I'm going to recommend something I think is going to work for somebody and the situations that they need it to work on reliably and having enough power. And this Makita probably costs twice as much as the Dremel, but it does have a 3 amp motor versus a 1.5 amp motor, even though they both oscillated about at 20,000 times a second. Which I think is 21,000 on the Dremel and 20,000 on the Makita. Quick release system on the Makita. Makita actually comes with these adapter plates, and that's another reason I can recommend it, is because basically when you get the Makita, it doesn't matter what blades you find, whether they're Dremel blades or old Fine blades or whoever's blades, you can use them with this tool, as well as the base diameter here not being small like the Dremels, but being the large OIS standard. So either way, you can use universal blades or anything with the Makita, and that was really smart of them and eliminates all the issue. And the Makita does have some disadvantages, though, for some people who may use it more occasionally. It's a contractor grade tool, so it's just huge. It's way larger than the Dremel. It probably weighs twice as much as the Dremel. The head is much larger, much thicker than the Dremel's head, because it's a contractor grade tool. It has an absolutely massive spindle and a very heavy duty mechanism in there, which holds just super duper tight. This thing has never developed any addition. It has a couple thousands to play, and it has stayed that way the entire time I've had that. So this is what I'd recommend, but we'll do a little comparison between the Dremel and the Makita for funds. But that's kind of my deal for picking up this Dremel, is just the fact that it is, just for those facts, is even though it's not a contractor grade quality tool, there'll be several situations where I just need to do simple little handy cuts and don't want to grab the big old contractor tool. There is some things to be said to having a much lighter weight tool that really has a low profile head that's really easy to see around. I'll do a little test cut here between the Makita and this to see if we can really see much of a cutting performance difference. Obviously, as tools like this wear out, the blade moves less flar, and then the cutting performance really can be dramatic. Or the difference can be really dramatic between one that's tight and good and one that isn't. So we'll see how this holds up. One thing I will say is this happened to randomly have this Dremel scraper blade, and actually I really like this flexible scraper. That's a nice, pretty good, as far as flexible scrapers, that's actually a pretty nice one. I've just done stuff like taking old blades and just converted them. Anyway, let's go take a look at these. All right, I'm going to do a quick little cut demonstration here. This is to see if there's an obvious difference in performance between these tools here. Shouldn't be too much. So one of the things I've noticed about these tools is one can seem to operate good, but when you start cutting with it, it doesn't do very well. And I'm actually happen to have a couple of these pretty good condition wooden drywall blades from the Dremel and with adapters. I'll be using the very same blade on both of these tools. I'm just going to go across here. You know, a big advantage with these is doing plunge cuts. You have the narrow blades like this, so you can actually do things like custom mortise and tenons because you can drill holes and then use a blade like this to actually square out the hole instead of using a chisel. There's all sorts of interesting uses for these just because they're really good at cutting plastics. They are loud. That's probably the biggest issue with them. These are just a vibrating tool. It took a minute for it to sink down. I probably got down about a ½ inch, so I'll go about the same distance with the Makita. Show you how far I went. Get that in there. The blades do get pretty hot because they're just based off of friction. Actually, I should probably just go sideways with it, but I'm making sure I get enough force. So maybe a half or so in just on a plunge cut. And I'm not sure how long that took, but it was not too bad. These are not super fast cutting tools. They're not circular saw blade tools. They're made for fine precision cuts, but it's surprising that just a little bit of a difference in oscillating difference, or distance I should say, how much it rotates back and forth, as well as once again having a very tight mechanism, so every bit of motion that the motor's delivering is actually going into oscillations of the blade. This Dremel blade looks funny on this Makita. It almost looks comically small just because how much bigger a tool this is. We'll crank this one up. I wonder if it's actually quieter. I should mention the Makita is about half the volume at maximum power as the Dremel. Wow, that Dremel is loud. And you just saw smoke coming out of there, and I can see that I've effectively buried the Makita in that block of wood. That was, unlike my Bosch interview, that was literally twice as fast. I'm going to do that one more time because I wasn't expecting that big of a difference. That was actually kind of crazy. I'm going to do the same thing, I went way deep. I went deeper with the Makita. Come on. Focus for me. Focus down here. You can see how deep I went on that blade versus the Dremel. I actually went a lot deeper. I'm going to try it one more time with a bit more force behind the Dremel. Okay, that was a little bit more fair. I put a little bit more force down the Dremel. We can see I did go quite a bit deeper. We'll do the same thing again with the Makita, just to see if we can't let me plug it in here. All right, here we go again. Make sure that's cranked all the way up. Do it this way. Alrighty. Sorry about the framing on that. Pushing a little bit harder. The Makita even showed itself probably more so. Definitely a better tool, and the difference is just how much control, how tight this darn spindle is. If I have this blade and this spindle, I can't even get it to rock, but it feels perfectly tight. There's just, even the Dremel, which only has just a few thousandths of a bit of play, surprising how much of a difference in performance. The Makita is more powerful, but both of these are supposedly oscillating at 20,000 times a second. Didn't really sound like either one was bogging down, just doing a full plunge with a half moon blade. The big difference is the Makita just delivered while making half the noise. Anyway, I'm going to take a quick look under the back cover just to inspect the commutator and see how the brush mechanism works, and I'm going to pull off the front gearbox. I should mention, versus like DeWalt's Porter cable quick release, the Makita system's probably the best that there is. See, when I was using that adapter and it just sits on top of there, it's just super easy to use, but you swap a blade, put the bolt back in. Even though that's a little bulky, I've read where this handle comes a little loose, it's still one of the better quick change systems for these too. Alright, let's take a look at the motor. I like using those wrench pouches for things like this with my American-made Torx driver set. It looks like we've got a little screw under here. Sorry for my poor camera framing when doing that demonstration. I went to go, that was actually the second time I screwed up the first time. Some days it just doesn't work out for you. There's an extra little screw under there. So everything is Torx on this. That kind of looks like a T10. And I just pulled out a T9. Where's my T10? Right next to it. Right there it is. Got one little screw there, and those are probably T15s down in there. Well, that works. It's feeling a little bit loose. See if we can figure out what grade of plastic. Kind of odd that they use a small little screw in the center there. At least it's relatively serviceable. Having Torx screws or the star screws are, generally speaking, a preference in power tools just because they're a lot easier to deal with than Phillips head fasteners. And there's our plastic casing. Let me see if I can find the grade of plastic. We can see other evidence of how cheap this tool is. It appears to be fiberglass reinforced nylon. We can see just almost a kind of a sheen, sparkly kind of. I don't know if you can pick that up on the camera here, but it definitely seems like there's fiberglass in there. The brushes holders are real basic. It just seems like a real basic kind of motor. There's a micro switch, so the actual tool switch just has a slider that activates a little micro switch. There's our little variable speed control board. Fortunately, on tools like this, when they seem to randomly stop operating, a lot of times it's this control board. And at least on a tool like this, you can modify it where the power wire just goes to the little switch, and it'll just be a simple single speed. At least it's nice to do that. They do use finger press quick release connectors for the power cord. So even though it's a proprietary power cord, meaning it has integrated overmolded strain relief, which is what holds it in the tool, these are a real hassle to deal with if you can't find the exact wire, which is a little bit disappointing. So I think it's funny that they include an easy disconnect replacing the power cord if you can get a hold of Dremel's proprietary power cord. Otherwise, these are just Bakelite brush guides. Nothing special. This is not made to do all-day work and get burning hot, because these brush guides will end up getting soft. Pulling these screws out, I'm not super fond of them because they're not using what's known as plastite screws, which are screws like this, but they just have really over deep threads for gripping into plastic. Instead, they're using more of like a standard type of screw, but then they have these odd corrugations that they're using to attempt to prevent them from coming loose in a tool that vibrates so much. All right, let's hope the whole motor doesn't yank out of here when I remove this, and good, it doesn't. So that's literally how these things work. It's really surprisingly simple, and that's why it's so critical that everything is really overbuilt and machined super duper tight. One, they didn't put much grease in there, but they are using sealed bearings. There are at least a couple of good things going on inside this Dremel. At least I can give it that. One, this mid case here is cast aluminum, so offering much more rigidity, which I'm surprised. They're using a large ball bearing for the end of the motor there. Good sign. This little post here. I should also mention that that controller inside this seemed a little bit more complicated. It is indeed a load compensating controller, so that is nice. You can tell, by the way, when you turn it on, it kind of ramps up and then catches itself. But this is where the rubber meets the road. This little post is actually not machined in the center. So as that goes roop, roop, roop around, all it's doing is rocking this fork back and forth. So the deal with the Makita is they just use a really large bearing and a very large oversized fork with this big surface areas on it. They just overbuild it so that it will last more, or last longer, I should say. The good news is there isn't plastic parts where the rubber meets the road. The whole drive mechanism is held securely by ball bearings. The drive is a ball bearing drive, so when it hits the side, it is able to rotate a little bit in order to reduce wear on the fork, and the fork is indeed steel as well. So at least I can say that about the Dremel is, surprisingly enough, it's better built than the first generation Bosches. I'm going to put just a little bit more grease inside here, but I'm actually happy to see that. I'm surprised that Dremel at least built this well enough so that it wouldn't just, you know, fail in the first 5 minutes. Maybe in the first 5 hours, but overall, in doing that little comparison cutting test with the Makita, kind of showed that I wasn't even surprised. It didn't, you know, it was definitely slower than the Makita, but it just didn't completely flounder. At least it still made the cut in a reasonable amount of time. All right, and to finish up this long power tool video, I realized I'm going to put a little bit of grease in there, but it's not going to do much good. It already has grease in there, and due to the vibratory tool, it just vibrates the grease to each side of the spindle. I think really the Achilles heel is, even though this drive mechanism is not bad at all, I think the biggest deal is when I'm yanking on this, I'm getting just a little bit of play in and out, just a tiny bit of wobble. And so that right there, if the spindle isn't held super tight, then when the drive mechanism's hitting the fork, it's causing the spindle to want to rock back and forth instead of rotate and deliver your energy. And so I think that's really the Achilles heel. Let me pull off this thing and see if there's at least a bearing on that side. Well, that was surprisingly easy to come out of there, and that kind of explains, I think, a little bit of the issue, is that this little plastic thing on the bottom of the gearbox was just pressing on the top of this bearing, and that's apparently what holds the whole spindle in. Like, you break this, the spindle falls out completely, out of the tool, just like this. I was like, wow, it just pulled right out. So we can see it is supported on both ends of the spindle. It is a pretty decent, this is bigger than a skateboard ball bearing, rubber sealed ball bearing, so they definitely were trying. And if I get a flashlight in, yeah, I need a flashlight. I'm tired of needing flashlights in my videos. I wish cameras actually had good dynamic range. If we get some light in there, if we can get just, you can almost see it, but it is indeed a little needle bearing down the back. So that's not a bronze bushing, and that's actually bodes pretty well. It should last longer, especially under this type of vibration that this is going on or experiencing. But I'm actually surprised. As far as I can tell, this is all ball and needle bearing construction. So Dremel was trying. It's just so surprising to have that plastic cap just be what governs whether or not this spindle stays in the head of the tool. And a better system in there would have resulted in a little bit tighter spindle, but it also helps explain why it at least was performing halfway decently. So there you have it, my excessively verbose review of the Dremel 6300. It is this, at least the 6300, or at least they used to be made in Mexico, so at least it's a North American tool, and they actually assembled it pretty well. In my experience, Mexican-built tools are actually pretty good. And overall, this thing is kind of pretty good considering what it is. It's light duty, but it has a load compensating variable speed. Not the heaviest duty motor, not made for heavy duty, high, high stress workloads all day long, because it would eventually melt down those brushes. But for a weekend warrior, this is actually a lot better than the Harbor Freight. It's certainly better than the early first generation Bosches with their plastic drive parts. That was just a nightmare. It was one of the, it was just a complete failure on Bosch's part is really surprising. So this Dremel, seeing the aluminum diaphragm or mid-frame in there, surprisingly enough, all ball and needle bearing construction. At least Dremel was actually trying to make a tool that would last a reasonable amount of time rather than being just entirely throwaway. Meaning use it 10 times and it becomes worthless. So overall, if you can get one of these used for a reasonable price or even new, and they're on a good sale, to tell you the truth, for anybody who's a weekend warrior or more of an occasional user, I could easily see this Multi-Max being just fine. And for anybody who actually is doing contractor stuff, using a tool like this every day, then I would recommend the heavier duty Makita. But this thing, actually, I'm going to enjoy having because it's just going to be simpler in so many situations. Just to grab the easy, lightweight Dremel, I actually think this hook on the handle was a wise idea, just because when you're using it, it's just a little bit easier to wield, and when you're carrying it around, it gives you a little bit of a lip just to make that a little bit more comfortable. So anyway, my review of the Dremel Multi-Max. I really appreciate everybody who's been watching and subscribing, and if you haven't subscribed, please do. Until next time, Catus Maximus out.